In this video and the next, I want to speak about rationalizing denominators of radical expressions. Remember, we said that a radical expression with a fraction is not considered simplified unless the denominator does not contain a radical symbol. So we have to figure out how do we express these radical expressions without a radical sign in the denominator. We're going to distinguish between denominators with one term and denominators with two terms. That will be the focus of the next video. But in both of these cases, we take our fraction, our radical expression, and we rename it by multiplying the numerator and denominator of that expression by a very specific amount that will allow us to eliminate the radical symbol in the denominator. Before we see how this is done, it's important to note that rationalizing denominators is not something that can only be done with denominators. You may also be asked in different contexts to rationalize a numerator, to rewrite an expression without a radical in the numerator. But for the focus of this video and this course, College Algebra, we're only going to consider rationalizing denominators. So here's how this works with a denominator that just has one term in the denominator. I want to rationalize, or I could have also said simplify, the square root of 3 over 2x. And we know from the quotient property that this is the same as the square root of 3 over the square root of 2x. Now right now, this is not a perfect square, and so I can't apply the square root. There's no way to simplify this radical expression in the denominator. We're going to choose to multiply this numerator and denominator by another radical expression that will give us a perfect power in the denominator. In this case, we're working with square roots, so I want to see a perfect square in the radicand of the denominator. 2x is not a perfect square, but if I multiply 2x times 2x, I will get the result square root of 4x squared. 4x squared is a perfect square, and therefore the radical symbol can be eliminated. It can be applied to take the square root. Since I multiplied this by the square root of 2x in the denominator, we have to do the same in the numerator. That's how we keep our expressions or our fractions balanced. So we're multiplying this by root 2x over root 2x. Here's the denominator. The numerator is now root 6x. The whole purpose of writing that was to get a perfect square here, which we can now simplify or apply. The square root of 4x squared is simply 2x. The numerator stays as root 6x. And we're finished. We've rewritten this expression as an equivalent expression with no radical in the denominator. That's our goal when we're rationalizing denominators. Let's look at another example. Here I want to rationalize 8x over the cubed root of 9x. Because I'm working with a cubed root in the denominator, my goal is to multiply by another radical expression that will create a perfect cube in the final denominator. So we're going to multiply this by some amount in the numerator and denominator that will give me a perfect cube inside the radicand right here. So what perfect cube can we create? Well, 9x is not a perfect cube, but 9 times 3 is 27. So if we multiply by the cubed root of 3, that'll give us a 27 here. That's a perfect cube. X is not a perfect cube. We would need it to be at least x cubed. So let's multiply by an x squared here, and that gives us the final result of x cubed. So notice how my goal was affecting what I chose to multiply by, right? I know that I need a perfect cube here, so I multiplied by whatever amount would give me that perfect cube. In this case, it's the cubed root of 3x squared. We also need to multiply by that same amount in the numerator. Now, the numerator doesn't look very nice. I have this coefficient piece on the outside and variable, and then I have this radical piece. I just have to express them multiplied together like this. But the denominator is now a perfect cube, and so let's apply the cubed root. The cubed root of 27x to the third is 3x. That's our denominator. In our numerator, I have 8x cubed root of 3x squared. Now I can simplify this a little bit because I have a factor of x, and it's outside a radical symbol in both the numerator and denominator. So that divides out as a common factor, and I'll write my final example as 8 cubed root of 3x squared over 3. Terms within a radicand do not divide out with terms outside a radicand. So I can't divide this 3 and this 3. They're not equivalent factors. Here's our final result of simplifying. You know, in some cases, our final answer looks more complicated than what we started with, but remember, we're meeting this very specific goal of rationalizing the denominator, of rewriting it in any way so that the denominator does not contain a radical expression.